Okay, in this video we are going to do some multiple choice review problems. There won't be answer choices because making answer choices is terrible. All the questions are based on previous AP exams, and you can find a link to the problems in the description. I definitely recommend you get them, try them out, and then watch the video to see if your solutions agree. All right, so let's get started. All right, our first question. We're going to go, if the integral from 5 to negative 3 of f of x dx is 6, from negative 3 to 4 is 8, from 2 to 4 of f of 2x dx is 5, then what is the integral from 5 to 8 of f of t dt? So I see two things that are, well, three things maybe that are trying to screw us up. That last thing is f of t dt. That's not going to matter. That could be f of x, it could be f of u, it doesn't really matter. The first thing that I want to deal with is this one. So the bounds should be switched. So it's really the negative of the integral from negative 3 to 5 is equal to 6, which means that the integral from negative 3 to 5 of f of x dx is negative 6. So I'm going to deal with that. Now what I like to do is go through and just look at all the bounds that I see. So I see that x is... I see a negative 3, a 2, a 4, a 5, and an 8. So to solve these sorts of problems, what I usually do is I make like these bar graph kind of things. So here's like my number line. I'm going to put all these values on it. And now I just kind of like underneath it draw bars to represent the things I know. So for example, that first integral, negative 3 to 5, I know is negative 6. I also know, because of the second integral, that negative 3 to 4 is 8. And since I know those two things, if you just look at it like in a physical sense, if I go negative 3 to 5 and I subtract negative 3 to 4, it'll give me 4 to 5. So now I actually know that from 4 to 5 is negative 6 minus 8, so negative 14. And then... So now at this point, I kind of realized that the 2 and the 4 that I used were sort of fake values. Well, no, the 4 is good. The 2 came from an integral of f of 2x dx, so I should have actually done a u-substitution there. So I'm going to look at this thing. Say u is 2x, which means 1/2 du is dx. And then if x is equal to 4, then u would be equal to 8. And if x is equal to 2, then u is equal to 4. And I can kind of like rewrite the whole thing, right? So it's going to be 1/2 the integral from 4 to 8 of f of u du is equal to 5. So then the integral from 4 to 8 of f of u du is equal to 10. So I'm going to add that in. So this here is 10. And then I can see the thing that I'm looking for is 5 to 8. If I go from 4 to 8 and I subtract 4 to 5, that should give me 5 to 8. So 5 to 8 is going to be 10 minus negative 14, which is 24. So the answer to this question is going to be 24. All right, so not a terrible question. Had like a couple of little tricky things to do, but I think we got it. Let's move on to the next one. So if f is the function given by f of x equals natural log of the quantity 5 plus natural log of x squared, then write the equation of the line tangent to the graph of f at the point e squared, comma, 2 natural log of 3 in point slope form. All right, so point slope form is really, really common. I'm just going to show really quickly why the ordered pair is e squared, comma, 2 natural log of 3. So this, because this is a review video, I would not do this on the AP exam. If they give you a point, you can use the point, right? So I'm going to substitute in, so it's e squared squared, right? Because I'm subbing into x squared. So e squared squared is e to the 4th. So I get this, and then this will be, so the natural log of e to the 4th is 4 times the natural log of e, and the natural log of e is 1. So that just becomes 5 plus 4. That's a property that you'll use sort of frequently, kind of down the road when you're solving differential equations. So this is the natural log of 9, but 9 is 3 squared, and the natural log of 3 squared is 2 times the natural log of 3. So that's why the ordered pair is e squared 2 natural log of 3. All right, let's actually do the problem. So this is my function. I'm going to copy it down because I like to have it like right above where I find the derivative, just a preference. So we got this. All right, so f prime of x is going to be derivative of natural log is 1 over u. This is u, so it's going to be 1 over 5 plus natural log of x squared times the derivative of u. So the derivative of 5 is 0. The derivative of natural log of x squared is 1 over x squared times 2x, which is just 2 over x. So times 2 over x. Now we're going to sub in. So we're subbing e squared. So f prime of e squared is 5 plus the natural log of e to the fourth times 2 over e squared. Natural log of e to the fourth is 4 natural log of e, which is just 4 times 1, so 4. So I get 2 over 9 e squared. And then point slope form is what we're looking for. So y minus 2 natural log of 3 is 2 over 9 e squared x minus e squared. Okay, so you might also see that derivative as 2 e to the negative second divided by 9 for the slope, because I don't know how they would choose to write that exponent. Let's move on to the next one. The graph of the function f is shown above. Write a compound inequality putting 0 to 5, the integral from 0 to 5, the integral from 5 to 8, and the integral from 0 to 8 in order from least to greatest. Okay, so with a problem like this, what I typically do is just kind of like make up areas for the region that have this, that relatively work. Like, it doesn't really matter if they're completely right? So this from 0 to 5, for example, is like, it's inside a 5 by 3-ish rectangle, which would be like 15, but it's kind of a lot of it. We're below the axis, so I'm going to say negative 10. And then from 5 to 8, it's kind of like it's kind of inside a rectangle that's like 3 by 1, but it's a lot of that, and it's above, so I'm going to say that's about 2. And then I'm going to use those values to figure out what I'm trying to do, right? So this one I just said was about negative 10. So this one I said was about 2. And then 0 to 8 is just going to be negative 10 plus 2, so negative 8. Now I've got concrete values, and I just need to put those in order and write the inequality. So from 0 to 5 is definitely the smallest. 0 to 8 is the next smallest. And then 5 to 8 is the next smallest. And there you go. All right, let's take a look at problem number 4. So remember, you can like slow this down, you can pause it, you can rewind it. Don't complain about me going too fast is kind of what I'm saying here. All right, so we're going the integral from 1 to 2 of 2 times the quantity 3x to the fourth plus 1 to the 1/2 times x cubed dx. Every once in a while on multiple choice questions, they'll put, I think that x squared is in like the x cubed rather, is in a weird place. I think it should be 2x cubed and then the quantity. That's more normal. But I guess they're testing to see if you understand and if you're like really noticing things. I just think that's strange. All right, I'm going to do U-substitution. I'm going to go all the way through with U-substitution, so I'm going to also change the bounds. So U is going to be the thing in parentheses. So 3x to the fourth plus 1, which means 1/12 du is equal to x cubed dx. If x is equal to 2, so that's a top bound, then U will be 2 to the fourth is 16 times 3 is 48 plus 1 is 49. And then if x is equal to 1, I just get 4. All right, so completely rewriting my integral. So that 2 that's just hanging out there is still there. 2, now I have a 1/12. The integral from 4 to 49, u to the 1/2 du. So everything is a u value at this point. So 2 and 1/12 is 1/6. U to the 1/2. So plus 1 is 3/2. The reciprocal is 2/3. So it's going to be 2/3 u to the 3/2. We're going from 4 to 49. Now we just have to evaluate. These numbers are pretty bad. I don't know if the AP exam would have values that are this bad. 49 to the 3/2. So the square root of 49 is 7. So it's going to be 7 cubed minus 4 to the 3/2. Square root of 4 is 2, cubed is 8. So I'm going to say minus 8. And now I'm going to work this out. So 7 squared is 49. I have to multiply that by 7. So it's going to be 3, carry the 6. So 343. I probably should have that memorized, but I definitely don't. And then I need to do 343 minus 8, which is, 335. So I'm going to go with 335 divided by 9. So that's my answer. It's kind of a basic U-substitution fundamental theorem question. You run into those fairly frequently on the exam. So make sure you know what you're doing with U-substitution in particular. That's a really important skill. Okay. So you look at this and you kind of know this is going to be implicit differentiation. If 2x squared minus 3xy plus 4y squared equals 9, then at the point negative 1, 1, dy dx equals. All right, so we're going to have to find dy dx. So sometimes I remember to show this step. Other times I just dive into taking the derivative. The advantage of showing this step is you'll never forget that the derivative of a constant is 0. And I see a lot of people forget that. So let's see. So the derivative of 2x squared is 4x. Now we have a product, right? Negative 3x times y. So I'm going to do first negative 3x times derivative of the second, which is dy dx, plus second, which is y. Derivative of the first is negative 3. So I'm going to write negative 3y. And then this is a chain rule, right? So 4y squared is going to give me 8y times dy dx. So don't forget the chain rule. 8y dy dx. The derivative of a constant is 0. And now I'm just going to evaluate. So negative 1, 1. If I try to do this and I get some sort of weird thing like negative 5 equals 0, that means the slope is undefined. And I would go back and actually solve for dy dx and try to see why. But first I try to evaluate it. So I'm plugging in negative 1 for x and 1 for y. So that gives me negative 4 plus 3 dy dx minus 3 plus 8 dy dx equals 0. So there's 11 dy dx's and then negative 7, but I'll move it to the other side. So 11 dy dx equals 7. So dy dx is 7 divided by 11. Okay, let's take a look at the next question. A particle moves along the x-axis so that anytime t, where t is greater than or equal to 0, its acceleration is a of t equals negative 45 cosine of 3t. If the velocity of the particle is v of 0 equals 9, and its position is x of 0 equals 6, then its position at time t is x of t equals. All right, so I'm going to go from acceleration to velocity. That means do the integral of acceleration. So I need to integrate this thing. Okay, dt. All right, so in my mind, I'm thinking like u is 3t, so there should be a 3, a 1/3, negative 45 divided by 3 is negative 15, and then the antiderivative cosine is sine, 3t, and then plus c. Now we need to solve for c. So I did a U-substitution there, but I usually just do those in my head because they're, when you're getting ready for the AP exam, those kinds of substitutions should be like pretty quick. So v of 0 is 9, so let's solve. So it's going to be negative 15, the sine of 0, plus c is equal to 9. The sine of 0 is 0, so it's just c is equal to 9. Okay, which means that the function is, or the velocity is negative 15 sine of 3t plus 9. So to go from velocity to position, I need to integrate that. So I'm going to integrate negative 15 sine of 3t, and then plus 9 dt. Okay, so the same deal. I need to integrate basically sine of 3t. There should be a 3, so a 1/3 on the outside. So 1/3 negative cosine, but then there's already a negative 15. So negative 15 over negative 3 is 5. So 5 cosine of 3t. And then the integral of 9 is 9t, and then plus c. And then we know that x of 0 is 6, so we're going to solve for c. So x of 0 is 6. So I like to show like the substitution. So 5 cosine of 0 plus 9 times 0, which is just 0, plus c is equal to 6. Cosine of 0 is 1, so I get 5 plus c equals 6. So c is 1. And then we have our answer. So our answer, x of t, is 5 cosine of 3t plus 9t plus 1. And that's it. All right. Let's take a look at the next one. So hopefully you've been working on these ahead of time and now you're just like checking your answers. So let's see. The graph of f double prime, the second derivative of f, is shown above. So you always really want to keep track of what graph you're looking at. Also, to fit this here, I had to scale it a little bit. Usually the graphs are the exact same relative size, so you could superimpose them on each other, which makes it a lot easier. But the graph of the second derivative, so this is like a graph showing me concavity. Where's the function concave up? Where's the function concave down? Which of the following could be the graph of f? All right. So I look at this. It's a second derivative. Here are the zeros. So those are points of inflection because the second derivative has a sign change. And I know that on this interval, f must be concave up because the second derivative is positive. On this interval, f must be concave down. And then on this interval, f must be concave up. Okay, so there's another thing that I know that's actually really useful in this case. F double prime is definitely a quadratic, which means that f of x, so if I integrate that once, I'd get a cubic. If I integrate it again, I'd get a quartic. So f of x is actually a quartic, which is going to help me a lot to decide which of these is the graph I'm looking for. So basically I went from an x squared to an x to the fourth type of graph. So I can just cross out anything that's not x to the fourth right away. So for example, this is definitely a cubic. So it's this, as if they're asking me, if you misinterpret and you think that you're looking for f prime, you would probably pick one of the quadratic options. But this is, the cubic options. So this is cubic, so I can just cross it out. Now I just have to decide, is this fourth degree looking graph the one I'm looking for? Well, on this interval, that graph is definitely concave down, and the graph I'm looking for is concave up, so this is not the answer. So let's take a look at the other options. So at this point, you basically know the answer. You can look at, let me skip over that. We can look at this graph and say this is another cubic. It's actually a negative cubic, but it doesn't make a difference because it's a cubic, not a quartic, so it's out. And then this graph must be the answer by default. But if you look, on this interval, concave up. On this interval, concave down. And then on this interval, concave up, which matches what we were thinking in the original problem. So let's see another problem. Okay, so when x equals the natural log of 5, the limit as h approaches 0 of e to the 3 quantity x plus h. As soon as I see the limit as h approaches 0 in a problem on the AP exam, I immediately think this is probably the limit definition of the derivative. So then I would have to decide what the function is. But anyway, limit as h approaches 0, e to the 3 times the quantity x plus h minus e to the 3x over h is. So we're just looking for that limit at when x is equal to the natural log of 5, which means we could have just substituted that, but whatever. This is the way I've written the problem. It's probably the way it showed up somehow on some AP exam at some point in the last 50 years. So let's see. This question is really just saying, what is f prime of x for f of x equals e to the 3x? So remember, when you're looking at the limit definition, if it's written exactly as it should be, it's f of x, the limit as h approaches 0, of f of x plus h minus f of x over h. So you can find f of x in that top right of the numerator. So we're looking for this. And so now the question really has just become, let's find f prime of the natural log of 5, given that f of x is e to the 3x. So f prime of x, by the chain rule, will be 3e to the 3x. And now I need to substitute natural log of 5. So we get f prime of natural log of 5 is 3e to the 3 natural log of 5. Okay, so I'm going to use the property that coefficients become exponents for natural logs. So it's 3e to the natural log of 5 cubed, because the 3 became the exponent. And then e to the natural log of blah is just whatever blah is, because they're inverses, but that doesn't really matter. Well, it really matters, but it's not the point of the problem. And then 3 times 5 cubed. So 5 cubes is 125. These are very arithmetic heavy problems. 375. Okay, so that would be the answer. So we found the slope, basically, of e to the 3x at the natural log of 5 Had to do some properties of logs. It's a good thing to review. Another good thing to review is like the unit circle. Take a look at the unit circle. Think about the graphs of sine and cosine in particular. They can help you make sine charts on the exam. These are just random things that I'm throwing in here if you made it to this point in the video, which I don't know if you did. All right, let's look at number 9. If dy dx is equal to 1/6 x to the 6 plus 1/8 x to the 4th plus 5x squared minus 1. Okay, so that's dy dx. We're going to find the fourth derivative. I don't really know how to pronounce that in a better way. So the fourth derivative evaluated at x equals -2. All right, so I think they're trying to mess you up here and make you think you need to find y and then keep going from there. But there's no way I'm going to do that. So what I'm going to do is I'm going to find the fourth derivative. So the second derivative, there's definitely, this notation is good to review because it's like not the most common. So I'm just going through, power ruling my way through here. Bring down the exponent, subtract 1, bring down, and then the derivative of -1 is 0. Hopefully you can find that derivative of the polynomial. So that's the second. I got to find the third. Just means take the derivative of the second derivative. So power rule. Keep going. So we got 3/2, kind of messy, and then plus 10. What happens a lot though is you take enough derivatives that like the fractions kind of clean themselves up. And finally the fourth derivative. It's going to be 20 x cubed. Here, so it's 3/2, but then the derivative is 2x, so the 2's cancel. So we just get 3x. The derivative of 10 is 0. We're going to evaluate this at -2. So -2 cubed is -8 times 20 is -160. So this will be -160 minus 6, which is -166. And that's the answer. So let's take a look at what will be the final problem on this problem set. So let f be the function defined above. So it's this weird piecewise function. And then what is the integral from -2 to 2 of f of x dx? All right, so there's like jump discontinuity in this. So what I'm going to do is I'm going to break it up into 3 separate integrals that each deal with a different branch. So -2 to 0, and then x is less than 0, so that's 2x cubed. 0 to 0, because that's one of the branches of 3, and then 0 to 2 of 4 minus 2x, because 0 to 2 is greater than 0. Everything in there is greater than 0. So we have 3 integrals to do, which is super great. But it's just fundamental theorem. So let's do the first one. -2 to 0 of 2x cubed. So plus 1 times the reciprocal, so 2 over 4 is 1/2, and then x to the 4th from -2 to 0, which I'm going to do 1/2 and then evaluate it at 0. I just get 0. So it's going to be 0 minus, plug in -2 to the 4th. So -2 to the 4th is 16, but it's minus 16. And then divide by 2 is -8 for that part. The integral from 0 to 0 of anything is just going to be 0. So this part doesn't contribute anything. And then the integral from 0 to 2 of 4 minus 2x. So reverse power rule. So I'm going to get 4x and then minus x squared. And we're going from 0 to 2. So when I plug in 2, I get something. When I plug in 0, I get nothing, right? 4 times 0 minus 0. That's good. So it's really just going to be 8 minus 4, which is 4. And then overall, I want to add the 3 results. So I want to do -8 plus 0 plus 4, which is really just -8 plus 4, which is -4. All right. And that's it. So that's 10 problems, all of which were based on previous AP exams. They're exactly the level of difficulty that you need to understand and be able to work with. So I hope you found this helpful, and good luck.